I've provided you a checklist here on page 21 of your orange book. And again, as we've discussed before, there are going to be some things in here that may not apply every time. But I encourage you to use this as a memory jogger to ensure that you're not overlooking what could be some very critical information. Now, if I take a look at these particular notes, I have a real problem with these. You might recognize this looks an awful lot like my handwriting. This is a notes form that I have seen colleagues in the field use, and I characterize this as notes that are afraid that we're going to run out of pencil lead or run out of paper. They are minimalist, and they do not indicate when the surveyor has made check measurements. It's almost like surveyor shorthand. It may look neat, but as a professional, I have a real problem with this because I don't have a feel for how the survey crew went about checking their measurements, or if they even checked their measurements. But this simply says, with a backside at 2, they had an instrument sitting at 0.1. So here I've got 0.1. It says NBC set. NBC stands for nail and bottle cap. We'll often take caps from glass drink bottles, beer bottles, or whatever, and drive a nail through it and use that kind of like a washer to hold down some ribbon. And we'll drive that through a chip seal road surface or in a gravel surface and use it as a temporary point. So we're set up over a nail and bottle cap, and we backsighted 0.2, and this says they measured 0 degrees there. I think it's a whole lot better to say I set it. Not that I measured it, but that I actually set that. That becomes the basis then of all my other angles. The backside was to 0.2, which is a PK nail set. PK is an abbreviation for a brand name called Parker-Kalin. Parker-Kalin makes nails that you can drive into asphalt. And then they turned the angle right to this PSM. They picked up shots on a wood post, which is a fence corner, way out here in the center of this 1 mile by 1 mile section. And then they turned a foresight to 0.5. Now here's why I have trouble with these notes. Here that says I sat at 0.5 and I backsighted 0.1 and I turned a foresight to 0.6. But I don't have anything in these notes that says I set 0 at 0.1, do I? Now, some would say, well, you can assume that. Well, I'm sorry. When professional liability is on the line, I really don't like making assumptions. Anytime you set an angle in an instrument, you need to say so. These notes don't say so. These notes may look efficient, but they are sketchy. How do I know that they truly had 0 set on 0.1? Is it possible that they forgot? And maybe the instrument read 0 degrees, 32 minutes, and 15 seconds. There's a pretty good likelihood they didn't, because down here the sum of their angles is 540, 00, 20. But these notes don't make me comfortable about what's going on in the field. If I have the opportunity to measure a distance both directions, that is, I measured the distance from 1 to 5 and found it to be 2609.72. Don't you think I should, while sitting at 5 and backsighting 1, measure that distance again and average the two results? That way I have a direct and reverse. At least that would help me know if I made a blunder. When you're trying to hold the rod over the point, you know that that rod's going to move around a little bit. If the rodman wasn't ready when you took the shot and wasn't plumb, then the second time you take the shot, you should probably see a difference. You can work around this and see how these numbers go together, but you can see these are pretty sketchy notes. I don't like this. Here I've got 1, 2, 3, 4, 5 setups, and they've traversed 4 miles. I know they probably took more measurements than what you see here. Every measurement you take should be in your field notes. These notes here are not perfect, but they are much better, and I'll show you why. In these, this particular survey crew was doing single direct measurements. They weren't doing direct and reverse. fact, it's not uncommon that we do just single direct measurements. That's part of the balance between accuracy and economics. We do this to turn a profit. Once our confidence level is high enough, then rather than doing direct and reverse measurements, we'll often do direct measurements and build checks into our process to minimize the likelihood of errors. So sitting at 2, backsighting 1, here you can see 2, backsighting 1, and then you see point number, horizontal angle, horizontal distance, and a description. This says that, yeah, we backsighted 1 and we set 0. Oh, thank you. It tells you what the distance was and what the point was. IR and cap. This is iron rod and cap found flush. ILS 2318 is Illinois Land Surveyor, whose registration number is 2318. And here you can see what we call side shots. From point 2, before moving on to point 3, they took measurements to point 11 and point 12. Notice then, from sitting at 2, foresighting 3, you have a distance of 458.41. Well, then when we set up the instrument at point 3 and backsight 2, notice then, yeah, we measured 458.41, but we also, in parenthesis, showed the previous measurement. Why? So we can show that, hey, we're comparing. We expect them to be similar, but understand they may be a little different. For instance, the only thing we measured from point 3, foresight-wise, is point 4 with a distance of 339.26. Well, when we move forward to point 4, we shot 339.29 on the backside. All right, we're simply showing, yeah, we had a 300ths difference there. What do you think we'll do with that? We'll average those distances as part of our computational steps. Please understand, I started with my instrument at point 2. My first backsight was 1. If I have to measure every interior angle, well, I've measured the first one at point 2, the second one at point 3, the third one at point 4, and the fourth one at point 5, then my fifth angle will be measured at point 1. Here's something I do, and I recommend everyone do for data management purposes. You remember on our CAD file a little bit ago, we showed how the original point and the computed point have two different positions. When we deal with data collectors, electronic data collection, it'll be important that we don't try to give two different positions the same point number. Therefore, when I'm sitting at point 5 and I'm taking a final foresight on point 1, I show point 1 in parentheses and I give it a new point number, perhaps one that ends in 1. So I'm calling it point 21. Point 21 is actually will be my calculated position of the original point 1. In fact, you'll see here's my 428.14. 428.14, that's the foresight distance. Then you see the backsight distance. And then my original distance shot, my original backsight was 1170.70 down here. And then my foresight distance onto point 2 was 1170.72. Notice I've also got a computed position of point 2. So I have two original positions, two computed positions. It's important that you keep those two separate. All right, before I pick up the instrument from the last setup, I'm not going to assume anything is right until I've checked closure. In fact, when I'm on a survey crew, I almost never run the instrument. I have my instrument person doing that for me. They're running the data collector and the instrument. And then I'm out with the rod and the field book in hand and radio and other tools that I may need. I may have a camera in my hand to take a picture of things, be able to measure up some things that are going to be deciding factors in my boundary survey. I will tell the instrument person once I've got that last measurement recorded, sit tight while I check closure. And you'll notice that in these 5 setups, there are angles that are specifically foresight angles that determine the angle to the next point on my irregular polygon. That is, angles on the loop. Those are when I was sitting at 2, four-siding 3. When I was sitting at 3, four-siding 4. When I was sitting at 4, four-siding 5. Sitting at 5, four-siding 21. And sitting at 21, four-siding 22. You can see a little squiggle line under those, so I can tell which ones they are. I've simply copied those over here to my closure check, and I can sum them down and find out that indeed I am 20 seconds under. I do my allowable calculation, and I can show myself that yes, indeed, I have met angular closure standards. In terms of turning a traverse with single direct angles, this is a very basic set of notes. Certainly they're not perfect. They could be criticized for a handful of things. Most of those I believe to be stylistic and not content. When you're out in the field, it's going to be imperative that you record every measurement as it is taken. This will be essential to avoid making mistakes based on your memory. If you do make a mistake, you can see here in this first setup. Don't scribble it out. Don't erase it. Simply line through it so it's still readable. It's okay to admit that you made a mistake in writing. Line through it and then put the appropriate value close to it so that it's clear what was erroneous and what is correct. You have a lab coming up that'll be a two-part lab. We'll be working outside, doing a traverse very much like this one in these notes, has probably at least a 5-sided loop and some side shots, because we will not only measure this up, but just as you can see here in this particular survey, once we know the coordinates of the boundary points, then we can compute the distances and the directions along the sides of the boundary, thus enabling us to measure indirectly between the boundary corners.